We are working on naming and writing formulas of covalent compounds. Covalent compounds are also called molecular compounds or molecules, and we use only non-metals when making covalent compounds, and the location of non-metals on the periodic table is on the right side of the stair step. All this carbon, nitrogen, oxygen, chlorine, sulfur, bromine, iodine, all these elements on the right side. All right, those are the one we use when making covalent compounds. So let's start with just quick comparison with ionic and covalent. Let's take CaCl2 on this side, AlNO3, and one more example. Okay, so this side, and let's write on this side just to compare. So here this one is ionic. How do I know? Because this is made from two ions, calcium ion and chloride ion, right? And again, this is aluminum ion and nitrate ion. We have positive ion and negative ions. Here ammonium ion and phosphate ion. So generally you're going to see that ionic compounds always have a metal, like a first element is a metal, calcium, aluminum, but in this case you don't see any metal. However, this is still considered ionic because the first part is from cation, which is ammonium, and the second part is from anion, which is phosphate, ammonium phosphate. And so that's how it is going to be real quick. And this will be aluminum and nitrate ion, and this one ammonium positive and phosphate negative. Now here these are covalent compounds. How do we know? Because you do not see any metals at all. Carbon and oxygen, they both are non-metals. Okay, so is hydrogen and oxygen. What happens when you look at the periodic table, sometimes you get mixed up. You may think that hydrogen is a metal just because it's right here at the very top, right above the alkali metals. However, it is a non-metal. Okay, so hydrogen and oxygen, they both are non-metals. Similarly, carbon and chlorine, they both are non-metals. So you can tell that these are covalent compounds. No ions at all. Now here we are talking mainly about binary compound, but covalent compounds can have, let's say, ethyl alcohol or ethyl alcohol. 1, 2, and 3. 3 types of elements here. So it doesn't have to be always binary, but I'm just talking about binary in today's lesson. All right. This is also a covalent compound, as you do not see any metal here. It's all non-metals and no ions at all. These are all molecules. No ions, but here you have ions. Okay, monoatomic or polyatomic, that you have already learned. Let's start with the rules. There are 5 rules for naming covalent compounds. The rule number 1 is that name of the first element remains same and the second element ends in IDE. So this is very similar to the name of binary ionic compounds, but however the second element is not ion even though it is ending in IDE. Okay, there are no ions at all in covalent compounds. So you have carbon. When you name this, name of the first element remains same, so you write down carbon. Okay, and the second element ends in IDE, which will be, this is oxygen, so we'll end in IDE oxide. Rule number 2 says use prefixes. So we have to indicate the number of each atom by using prefixes. How many carbon do we have here? We have 1 carbon, so we can write mono. All right, and we have 2 oxygen, so di. And we said oxygen is oxide. Now here, this is the chart I'm using. Look here. And this is on Google Classroom already. So when you do your homework, make sure you use this chart from Google Classroom. Here for one atom, the prefix is mono, 2 atoms is di, 3 atoms tri, 4 atoms tetra, 5 is penta, 6 is hexa, 7 atoms hepta, 8 octa, 9 nona, and 10 deca. Okay, once again, this is already on your Google Classroom. Then it says there is the next rule. So we use the prefix to indicate the number of each atom. These are the prefixes mono and di. But then rule number 3 says do not use mono for the first element. So what are we going to do? We are going to cross out this mono. And this is only carbon dioxide. Okay. So these rules, 3 rules are shown in the name of this compound, carbon dioxide. Just remember, if the second element is only 1, then you will use mono for the second one, but you do not, however, you do not use mono for the first one. Okay, guys? All right. Okay, so now rule number 4, if there are 2 O's, letter O, then you have to drop the first O, the first letter O. Here you have CO. Remember, we do not use mono for the first element, so we are going to say carbon, and the second element is 1, so mono. I'm going to write it like that, mono oxide. Okay, guys, it is mono oxide. All right. So, and then it says number 5, drop the letter A. Well, not here. We got to follow this rule, mono oxide. If there are 2 O's, we cross out 1 O. So this is just monoxide. Carbon monoxide. Do not put 2 double O's. The number 5, drop the letter A from the prefix if an element's name begins with the letter O. So here you have 2 nitrogen. So di-nitrogen, all right, dinitrogen. You have 5 oxygen, so it will be 5 is pentaoxide. But again, we are following the rule, drop the letter A from here. And we have dinitrogen pentoxide. So this is the correct way to name, dinitrogen pentoxide. Okay, all right, so these are the 5 rules. Now let's do the learning check if you actually got it or no. Okay, right here. You can pause the video and try on your own. Okay. All right, now come back and double check your answers. You have nitrogen. We don't use mono here, just the nitrogen. You have to fill up these. This is mono, M-O-N, and we are not going to use another O. Remember, not 2 O's, so monoxide. Right? Nitrogen, you have this one, dioxide. This is carbon, and then you have 4 chlorine, so tetrachloride. This one is 4 iodine, so 4 again is tetra. Remember, just remember the name of the first element remains same, and the second one ends in IDE, and you're using prefixes. So tetra iodine, but this is 9 oxygen, so non-oxide. Okay, you do not write N-O-N-A here, no A here, because A and O, whenever you have A and O, you cross out, you drop letter O, A. So this one is non-oxide. Let's do a little bit more check for understanding. Let's see. You have to pick the right answer. Just pause the video. Well, if this is the one you picked, that means you understood it right. Sulfur tetrafluoride. We do not use mono, And also here we didn't use the prefix for fluorine, so they both are incorrect. Now number 2, if this is the one you picked, B, that means you got it right. Because here you have 4 phosphorus, we did need a prefix and it's not used here. Here we did use prefix for both of them, and the last one is incorrect because we did not use prefix for oxygen, which is oxide. This one was the tricky one. If this is the one you picked, then you found out that I was trying to trick you, because this is not even a compound. This is an element. Even though it has covalent bonding, but it is not a compound. It is still an element. Okay, so we do not use prefixes for element. We are just working on naming compounds to show the number of atoms of each type of atom in those compounds. So no prefixes for elements. All right. Okay, so now let's work on writing formulas. Make sure you have your periodic table and you use your prefix chart. So here carbon, you're going to look at the periodic table. Carbon is C, disulfide. So you need periodic table and you need your prefix chart. What does this di prefix stand for? How many atoms does this di shows? Di shows 2 atoms. And 2 atoms of what? 2 atoms of sulfur, because it is sulfur and then sulfide is the IDE is the ending for sulfur. Just remember this 2 goes here. This little subscript, the prefix that we use is always used before that element. So this is not for carbon, this is for sulfur. That's why it is disulfide. Here dinitrogen trioxide. So we have di. What is di? Di is nitrogen. Okay. So nitrogen, how many? Di. And how many oxygen? Tri. So you put here 3. So 2 nitrogen, 3 oxygen. So this one, the formula writing is pretty straightforward. Guys, overall, in general too, the naming and writing formulas of covalent compounds is much easier compared to ionic compounds. So try this one. Your turn. Pause the video. You're going to use the periodic table and you're going to use the prefix chart. Sulfur dioxide. Nitrogen. We do not use mono for the first element, but for second, yes, we can. I mean, we do. We do use mono for the second one. This is nitrogen monoxide. Okay. Now let's compare and contrast naming and writing formulas for ionic and covalent compounds. When you are writing, so ionic compounds are also called as formula unit, covalent compounds also as molecules. So you use valency chart for ionic compounds, and valency chart shows oxidation number. You use prefix chart for covalent compounds. So we do not use prefix chart for ionic. We do not use valency chart for covalent. Okay, for ionic use valency chart, for covalent use prefix chart. And for ionic compounds, in the final formula, we usually reduce it to the smallest ratio. Here is an example. There are certain exceptions that I have already talked in my another video of ionic compounds. So here, like this one, Mn2O4, which is manganese 4 oxide, is written as MnO2. All right, you divided both this subscript by 2 and this one by 2. However, we do not reduce subscripts to the smallest ratio in covalent compounds. So these are 2 different compounds. P2O5 is diphosphorus pentoxide and P4O10 is tetraphosphorus dicoxide. The whole idea, like the main reason to use prefixes with covalent compounds is because the same element can make several compounds. Like here P2O5, P4O10, You also did an example of CO. You did CO2. Then you did NO. You did NO2. You did N2O5. So all those, so you had done CO, CO2, you did NO, you did NO2, you did N2O5, and now these two. So they are the same element, but they can still combine in a different ratio to form different compounds. That is why we need to use prefixes for covalent compounds. However, when you're working on ionic compounds, let's say you're making ionic compounds using calcium and chloride ion, all it can form is just one compound, CaCl2. That is the only combination possible. So we do not need to use prefix chart. All right. Hope this helps. All right. Thank you, guys.